Hello everyone, I'm delighted to welcome you to the inaugural lecture for Professor Gary Burnett. It's a real privilege to introduce inaugural lectures. I'm actually here today on behalf of the Pro-Vice-Chancellor for Faculty of Engineering, Professor Andy Long. I'm Sarah Sharples and I'm the Associate Pro-Vice-Chancellor for the Faculty of Engineering with a focus on research and knowledge exchange. But I'm also a Professor in Human Factors, and so in the same research group as Gary, so it's an extra privilege and treat to introduce this particular lecture. Now, an inaugural lecture is a really interesting one-off activity that recognises the tremendous achievement that it is to receive promotion to professor status. As I've done before, actually, I did a little bit of Googling, although the university network's down, so that was harder today than normal. Edinburgh University define an inaugural lecture as being an illuminating overview of the contribution to their research field. And Bristol University describe it as an unmissable rite of passage. A fantastic occasion to bring together family, friends, colleagues, students, and the general public. This is a public lecture of the university as well. I think the way that I would sum up an inaugural lecture is a bit of a point of reference within your career. It's a recognition of achievement, but it's also a real opportunity to reflect and think about your future ambitions for the large portion of your career that is still remaining. Now, Gary is based within the Faculty of Engineering and is a civil engineer by background from his first degree. After a short spell in industry, after completing his first degree, he went to Loughborough University where he completed a Master's in IT and Human Factors. He worked for a research institute there called HughesSat, which at its time was, from my opinion, really one of the world-leading institutions that took together human factors and technology in a situated context. And when Gary was working there, he embarked on a part-time PhD while also working on a range of projects that were primarily funded by industry. He wrote me a few notes and noted a couple of influences that I think were really important to his career while he was at Loughborough, Andrew Parkes and Mark Porter. And I know both of them, and Mark sadly died several years ago now, but they were both really inspirational characters in terms of thinking about the context of the research, but also thinking about the ambition that we can bring to our research. So it's not surprising that Gary's been so successful, having had such a good start in terms of the mentorship and the colleagues that he received while he was working there at Loughborough. However, of course, he saw sense and came to Nottingham after a few years. And joined Nottingham University in 2000. He joined actually to one of the other parts of the university in the School of Computer Science. And I was trying to remember when we met, and I honestly can't remember, but I think it was quite early on in his career. And we actually built up a partnership between human factors based in engineering and the computer science-based work that Gary was then conducting. An opportunity came up to actually move to human factors as an associate professor in 2008. And really since then, Gary's career has gone from strength to strength. Alongside his work, he described himself as a committed breakdancer in his 20s, travelling around the country. And he has asked me to emphasise that he's no longer a committed breakdancer and won't be including that within the inaugural lecture.
It ain't going to happen.
We can try. He's also now very much a committed athlete. Got a very impressive 2 hours and 44 time in the London Marathon a couple of years ago. He claims he managed to get a bit of a race with Mo Farah, but I'm not sure it lasted very long. And is now actually aiming for a world record in the 4x800 metres this summer in the over 50s category. But that actually will be a tremendous achievement. I wouldn't be eligible for that category, Gary. But actually, in terms of an inaugural lecture, I like to sort of reflect on what the distinct contribution of the individual who I'm introducing brings. And I think there are two things that I'd particularly highlight about Gary. The first is the clear contribution in terms of both research excellence and impact in the real world. One of the things that we really strive for as researchers in a leading UK institution is that combination of absolutely excellent science with meaning, inspiration, and translation into the real world. And I think that what you'll see today will demonstrate both of those elements. And it really is important, both from our strategy, but also from making sure that the work that we do in the university has real meaning and relevance. The second thing is actually, I think Gary's one of the people who really makes sure he brings his research into his teaching. He always gets outstanding scores in his teaching. There's perhaps a bit of a myth that you become worse at teaching as your career progresses within a university. I don't think that's the case at all with many of our colleagues. And Gary is certainly one who I know from discussing with students really brings his enthusiasm for his research as well as his knowledge into enhancing that student experience through teaching. So I think that's something that we should really recognise. I think the last thing is, Gary, when he wrote his little note to me, he said, whilst it's possible to gain an international reputation for research, there aren't world records in research. Well, no, Gary, there aren't, but there are Nobel Prizes. So if you could just raise your game a little bit, then I'd really appreciate it. And that will help our strategy. So I'd like you to all welcome Professor Gary Burnett.
Thank you. All right, thank you, Sarah, and thank you all for coming. It's quite peculiar to see all these different people from different parts of my life all in the same room at the same time. This will never happen again, I think. It's quite strange. So, yeah, navigate, automate, levitate, human-centered design for future vehicles. Now, many of you will be aware of the obsession that my wife Sally and I share in the electronic music pioneers Kraftwerk, and we go to visit them. We go to see them in concert in their 3D concerts in a variety of different beautiful European cities throughout Europe. And here is us enjoying the sights of Amsterdam. Here is us enjoying the sights of Oslo. Here are the two of us enjoying the sights of Budapest, and here are us enjoying the sights of Dublin together with a convert, bringing along our son to the party. Now, this particular image was and this artwork was from my other son George, who was basically an impression of the Kraftwerk's 1974 album Autobahn. Now, in that artwork, like in this artwork, it gives a very positive image towards transport. Here, George has illustrated the image also with a navigation system, with the potential for automation within the system, with the platoons of trucks together with a flying car. Also all sharing the road transport network with classic Volkswagen Beetle. Now, this is a really positive image towards transport in transport of the future. And when you go to, what is the future of personal transportation, you can have these amazingly positive perspectives on transport, and many people do, and this is really important. But you can also have the other side of the coin. And a key argument that I'm going to be making throughout this talk is this importance for balance, for the balance between the overly positive views towards technology and the overly negative views towards technology. And human factors is particularly central to that balancing of tensions. Okay, first back to the beginning. Now, many of you, those who know me from my childhood, there's a few here, will know that I had a real obsession with go-karts when I was a kid, and I would spend days and days, hours and hours building go-karts. And this is me on the right, trying to look cool with my brother Paul, who is looking cool, with our go-karts that I'd built and designed and developed that that won a prize at the school fete. And you're thinking, this is great. This is an obsession that's clearly lasted for me for the whole of my career, all the way through. Because now I still build go-karts, but now I build driving simulator go-karts, and I get paid for it. So this is really nice. So this is something that's been with me for a long time. Now, okay, what I'm going to talk about. I'm going to talk about some trends in road transport. I'm going to talk about the potential for new technology within vehicles. Yeah, the human factors issues are changing all the time, particularly with the rise of automation, and that's really important for us as we go forward. I'm going to put forward this argument for balancing forces, and I'm going to talk about some of the research that we've done that I hope provides some balance in the design of new vehicles. 25 years of my life, what have I learnt? I'd like to feel at least a few things I bring to this, and yeah, some thanks to important people at the end. Okay, a few trends in road transport. So let's look at I'll come over here for this. Okay, going from 1950 all the way through to the present period, billion vehicle miles, this is UK transport, and this is road transport, and this has just been going up and up. Okay, there was a dip with the last recession, but it's going back up again. And these focus the minds of various people in research and politicians and legislation that we are getting more and more road transport still. And if you then look to fatalities on the road, the more sort of worrying figure, if you like, in many ways, and you again go 1950 to 2010, this reached a peak around the year I was born, about 1967, about 8,000 people a year dying in road traffic accidents. That's been dropping steadily, various reasons why for that that's happened, but it's leveled off in recent years. This starts focusing people's minds about what sort of radical changes might be required in order to change to change the situation. This is not just something happening in the UK. If we go, say, across the whole of Europe, and you look at the trends there, the blue line was the one set by the EU as the desired number of road traffic fatalities, and the actual situation followed that for a while, and then it started then it's leveling off. If you go to North America, to the USA, you can actually see it increasing. There are greater numbers of road traffic fatalities. These are the sorts of things that focus people's minds and particularly strengthen the arguments people put forward for higher levels of automation on our roads. Now, okay, potential for technology. Now, if I was thinking what the car of the future is, then for me, it would be the Audi TT used in the iRobot film of the early 2000s, which had all sorts of different technology, particularly automating technology, and was real. It's a really interesting film in terms of the tensions between between people's different attitudes towards technology. Now, we can think of the systems here that provide information and services relevant to driving. We can think of systems that provide non-driving related information and services that people have a desire for them, but they may have negative consequences. And then you can think of all those systems that are fundamentally changing the driving task, and this is clearly about automation. There are many positive reasons for technology in vehicles: safety, efficiency, comfort, productivity, entertainment. There are many different reasons why this is an important thing to do. Now, the thing about automation is that it's every other day there's a story about automation, about driverless cars, about high levels of automation. And people will have very different impressions of what is meant by automated driving. I'll talk about my impressions in a minute. You know, you can have the 1950s vision of automated driving with the perfect family in their vehicle, all having a board game. I'm not sure what it'd be like having a board game in a car with a bouncing around everywhere, but it is quite strange. And people think about pods, the sort of Google car type pods that we might be in the future, Think of platoons of trucks on our roads. Think of very sort of sci-fi, space-age looking vehicle interiors, seats that start turning around and facing one another, these sorts of things. But people also get into, okay, what would it mean for me? What sort of things could I do in this vehicle of the future? Well, I might be able to start using my phone a lot more. I might be able to become a model and start and start reading the works of Ulysses or whatever, and sort of taking it nice and easy. I might sleep a lot in my car, or I might start doing other things in my car. This is only a matter of time. But there is actually, handily, there's a nice standard for this, the SAE standard, which is a very useful thing to think about in terms of automation. I'll head over here again to do this one. And it goes from level 0 to level 5. Level 0 is no automation at all. Level 5 is the car will completely drive itself, doesn't even need a human in it, necessarily. Come pick you up from the pub when you've had too many drinks. And there are different levels of automation, and there are different issues as you move between them. Now, in terms of level 0, you cannot buy a car that is level 0 automation anymore. You've got to go back to the sort of car that Sally and I owned when we got married. 1967 Volkswagen Beetle. This was a lovely car. Not because it had no technology in it at all, but it was just the physicality of actually driving that vehicle was great. But you've got different key things that are going on as you move through different levels of automation. There's a key thing going from 2 to 3, where you go from the driver monitoring the environment to the system monitoring the environment, and a key issue going from level 3 to level 4, where the driver is the fallback situation if there's a problem, through to level 4, where the system is a fallback situation if there's a problem. Now, when people have started putting forward the arguments for why higher automation is very important, I've already mentioned the argument of safety. 90% of vehicle crashes have human error as a key contributing factor. Then that may well have an impact if we take the human out of the loop, particularly when you go to very high levels of automation. You have efficiency arguments. You have driver comfort arguments. It can be very stressful, particularly on certain types of journeys. People may not want to drive. They can take those stresses out. You have productivity. It's the fact people can do other things in these vehicles. And you have the arguments about mobility and inclusivity. Many people, as they get older, find it more and more difficult to drive, but they still want the personal freedom associated with the motor vehicle, and automated vehicles or high levels of automation may allow people to be able to drive for longer, or people who cannot drive at all, for instance, those with visual impairments. Now, it's worth thinking about, well, what constitutes the next level of vehicle after that? Okay, level 5, sometime in the future, maybe 20, 30 years' time, many cars on the road will drive themselves. What comes after that? Well, you could go into science fiction and go to the sentient car, the car that has a brain, and maybe the automated cars start building themselves as you move to the next level. Maybe you have the car that travels into the future. Maybe. I've been told by my son that that's physically, laws of physics will not allow that. Or maybe you get into Blade Runner and the car that flies. Now, the Levitate part of my talk now. The flying car. You have this quote, "Mark my word, a combination of airplane and motor car is coming. You may smile, but it will come." That was Henry Ford from 1940. This has been talked about for a long time. Now, it's interesting that you're now starting to see some prototype vehicles and actual vehicles you can buy that will be both flying and driving. Okay, you can go and it will cost you many hundreds of thousands of pounds, but these are developments that are starting to happen. And so we just recently started to think about this in terms of what the human factors issues might be involved. And Lydia, who's here in our MEng project, has just started for us building a flying car simulator. We've taken our Honda Civic Buck, and we're now actually set up a situation where you can be in a car and sometimes you can drive, and sometimes, they've got a joystick there in the center, you can actually fly. And you can start to consider these issues of, well, what sort of displays would we have? What would be shared between the flying and the driving? What about the controls? We may have steering wheel for driving. Maybe we have a yoke or a joystick for flying. And the movement between these two is really quite interesting. And it's very early days for this sort of thing. Now, okay, so I was talking about all these different types of technology, the different things that are going on. What are the human factors issues that are going on? Okay, let's go back to our level 0 to level 5. Now, the thing that becomes a big issue at these low levels, and has been for me throughout for quite a bit of my career, is issues of distraction and stress and workload. That diagram picture has been with me throughout my whole career, going back to the 1990s. The actual picture itself was from the 1980s, and it's this view about if you don't think about human factors, and you just bring all this technology into cars, you're going to have the poor driver being very stressed, very overloaded. You can tell this is a very old picture because it has attention incoming fax message. Okay, so we have these issues. Now, we've been thinking about distraction quite a lot, and just a study that we've just completed has been looking at some really interesting new technology. And this is technology that can provide in-the-air haptic feedback. So I can feel buttons without actually having to touch them, just in the air. And this is through ultrasounds. We're providing vibrations into the air, and you can feel pulses that you can relate to buttons. Now, when you start looking at this particular participant's eyes, and look at her hands as she does these tasks.
On this 3-item menu, press 3.
Go, watch her eyes.
On this 4-item menu, press 2.
So the key thing is that her eyes didn't leave the road. She's able to do these tasks without actually having to look at the display at all, because she's feeling buttons in midair. Now, not everyone was like this, but certain participants found that they could actually, just after a while, once they'd done this for an extended period, could start to carry out tasks without vision. That doesn't mean that there isn't cognitive demand, that they might need to be thinking about tasks, but they certainly could. There was the clear potential to do this without looking, which is not what you would get with a traditional in-vehicle touchscreen. Okay, so if distraction, workload, stress are these key issues associated with level 0, what are the other human factors issues that are going on? Well, you have issues to do with driver arousal and fatigue, can be important. So here we go, particular participants, a bit sleepy in their vehicle. You watch their eyes, and they're trying to stay awake. Now, driver arousal is important across these different levels. It becomes more important as you get further up the levels of automation, because you may need to be aware of that in order to bring people, to decide whether or not to bring people back. You can bring people back into driving or not, which is appropriate to level 3. Situation awareness is similar. We're interested in it at lower levels, but generally not in terms of the design of the vehicle. But as you get higher up into the levels of automation, it starts having a much more obvious impact on the design of the vehicle itself. Now, if you start going to the higher levels of automation, you start getting all sorts of different human factors issues going on. It's not just about distraction, workload, etc. We get issues to do with mode confusion, many issues to do with trust. Behavior change is a really interesting one, because it's not just about the people in the vehicle and how they may change their behavior with new forms of driving. It's the people outside the vehicle, the pedestrians, the cyclists, and how they may behave when they start encountering these very new types of vehicle on our roads. And one of the interesting things here, this relates to the weird picture with the car with eyes, is that there are concepts out there where you get into the car has eyes and it can follow you. So you think about the pedestrian who's not sure whether or not the car has seen them and is going to stop. You can't make eye contact with a car that's driving itself. But you may be able to with this sort of vehicle. And I saw a concept of this, and it was really peculiar. So I'm just crossing the road, and I can see the car's eyes following me across the road. And I come back, and it's following me the other way. And it's, these are sort of designs being sort of developed, being considered in relation to deal with this issue of the fact that we don't necessarily have a human-human contact when we start bringing in automation. Okay, so now it's time for a little bit of a history lesson. So most of you, you won't recognise this face, but you may recognise the name as Edward Ludlam, or known as Ned Ludd, who was the figurehead for the Luddite revolution of the 1810s that started here in Nottingham. Now, these are the people who destroyed the automated machines of their day. Now, there's no actual evidence that this guy actually existed, but he certainly became the figurehead for this revolution. Now, and obviously the words then come to mean a particular thing associated with technology as we've gone forward. But I'm pretty sure none of you will recognise this particular person, but this is Edmund Cartwright, who lived in at that time. He invented the power loom. So he was the guy who developed the patent for the power loom that then, certainly a number of years later, was associated with the Luddite revolution. Now, it's what Edmund Cartwright stands for, I think, to me, is particularly interesting, because this was a guy who worked throughout his whole career to develop this technology. He worked tirelessly, he worked very iteratively as he developed this the power loom. Many of his peers criticised him at this time. He didn't always develop the right technology, so he was also known for developing a steam-powered engine a steam engine that worked on alcohol and had a tendency to blow up. So he did certain things that made a big difference to the world and other things that he didn't. But he sort of represents that desire to consider carefully technology, to think very positively about it, and to embrace it, if you like, as you go forward. Now, to me, you get these fundamental tensions in the design process associated with this sort of negativity perspective, which can be very important to consider, but also the particularly positive view of the potential benefits of technology. Now, holding these different forces in balance requires something like human factors. Human factors is focused on the needs of the human and not necessarily the capabilities of the technology. You're interested in the technology, but your focus is very much on the humans. And there's a variety of different forces here. I'm not going to go through them, but I'll just mention one. That is the balance between revolution and evolution. So you can see this very much in car companies. This difference in perspectives between let's go straight to level 4, level 5, let's go for revolution, versus those who go, we need iteration, we need to progress slowly through and learn from what we've done at different points in the design process. And these, I would say human factors helps in a variety of different ways. It helps with good practice, methods and guidelines, so we can do the right thing, we can have the evidence. But I would argue it's the fundamental science, the theories, the predictions that are particularly important to be able to allow human factors, people who work in companies who feel these different forces, opposing forces, to provide the credibility in what they input within the design process. Okay, so what have we done? Okay, here's the researchers, PhD students within the automotive human factors part of the human factors research group, and we've been involved in lots of different things. I'm going to talk about HMI design for navigation systems. I'm going to talk about the prediction of driver distraction. I'm going to talk about validity and driving simulator studies, and I'm going to talk about some recent stuff we've been doing, particularly on natural language interfaces. I could have talked about a lot of other things as well, but clearly We have wine waiting for us outside, and I want to get to some sort of key things to talk about. So let's talk about navigation systems. My story with navigation systems goes back a long way. It goes back into right from the very beginning in my work at WhoSat, in one of the early papers here, and we did a whole set of road trials based in the Essex area, in the county of Essex, sort of around the Ford Research Centre in Dunton, the only part of the country at that point that had a digitised map that was produced. And we carried out a series of road trials with people using the early prototype navigation systems. These had a direct influence on a series of guidelines, which then clearly influenced the navigation systems that we see today now. And I want to show this clip, the clip from this particular road trial. At the time, these systems were called route guidance systems. Okay, no one had heard of sat-nav. They weren't called sat-nav. And it's worth seeing from this video just how positive the user experience was. You could see the potential for this technology. It was only a matter of time before this technology was going to become a really big thing. Okay, with these, as you saw it. So, excuse the cheesy music. It was free. So this was, you know, you could, to the people who were taking part in this study at this time, this technology was like magic. How does this car know where I am? It was, no one had heard of GPS. This was a big thing. Now, yeah, you're not allowed to be rude about that particular person who took part in that study. That was my mother-in-law. And it was a great participant. So now in terms of the guidelines that came from that research, they were formulated in things like the Hardy guidelines from an EU project. They were part of the Prometheus guidelines that went out to a lot of industrial partners at the time. There was a US project at the same time that developed many similar guidelines, and they clearly shaped the design of the interfaces for navigation systems. Just to show you some particular guidelines, guidance should be given in the form of simple step-by-step instructions at each maneuver. That's what we see in navigation systems. I won't read that one out, but you see this interface development. Now, I'd argue that things have changed from the early systems where it was simpler visual information, to a certain extent because of the characteristics of the displays that were around then. But as the displays have got bigger or got better high resolution, they've moved more towards map-type information being presented, at least visually, within these systems. And if you look at the types of information, then these are all types of information that you can see within navigation systems, perhaps with one exception. You don't see landmarks central within navigation systems, even though the arguments are very strong towards them. You can see some landmarks presented within displays now, which is a really good move forward, but not necessarily within voice instructions. Now, okay, landmarks. This is a big part of my PhD, and it's continued throughout various other projects since. There's various reasons why landmarks are really important. They're basic. Essentially, they fit very much with the way in which humans navigate, the way in which our brains, if you like, pardon to the psychologist, are wired to cope with, to deal with environmental information, the way in which we structure our knowledge of the world. And because there are both strong objective characteristics to a landmark and strong subjective characteristics to a landmark, you can have a very strong user experience associated with this type, their use within a navigation system. And there are many different reasons, ways in which you can predict a good landmark, and I'd argue it's the ones in red that are holding back that development within technology. It's the issues of permanence. Is that landmark actually there in shape and form and labelling? And issues of visibility. Is it actually visible? Now, we've done various things in this area over the years, but the particular one I want to point forward relates to augmented reality. So you've got a landmark like the one up on the left there, which is maybe it's not so visible because it's being hidden by trees in a particular time of the year with the greenery, and you may be able to use a virtual image onto your windscreen as augmented reality to highlight that landmark, to turn a not so good landmark in that particular situation into a much better landmark. And we've been looking at that in the simulator, where we can take a landmark and we can then start to put a box over it to highlight it, make it much clearer to the drivers in those sorts of situations. Now you then look at this in terms of people's reaction times and different types of navigation information. And basically, when people had the box around the landmark, they were much quicker to make a navigation decision. They were much more confident that they were doing the right thing as well. Now, the thing is about navigation systems that once the technology became really out there, it was evident that it's not just about distraction or about effectiveness in navigation. It's also a lot of issues to do with reliance and trust, behavior change, people not learning the areas that they travel through anymore. And we sort of moved on to thinking about issues of what sort of mechanisms are involved with people blindly following a sat-nav. Okay, what's going on in these situations? So this was the first time I started working with David Large in his PhD research, and we got into, okay, you've been following the sat-nav for an extended period, you get to this junction, you know you're going to Chatsworth House, and you get to this instruction, the road sign's right in front of you, and the Chatsworth House is pointing to the left, but the sat-nav says turn right. Which way do you go? Okay, and in this particular study with all our participants, we only found about a quarter went left and followed the road signs, and over 3/4 turned right and followed the sat-nav. Now, the interesting thing here is whether or not they were looking at the sign or not, because that starts pointing towards different mechanisms. And you found that actually, of those people who turned right, 64% of them were looking at the road sign. It's directly in front of them, but actually there's some people who are not looking at the road sign. So these are people who, there's an element of trust, but it could also be particularly an issue of attention. They're changing their visual scanning patterns associated with this. Now, the other thing that was going on here, or have I gone forward quickly too soon? This was affected considerably by the type of voice that was involved. We had a high trust voice, which was particularly associated with people turning right.
After 300 yards, turn right.
The people had rated that voice as being highly trustworthy, but then we had some other voices that had exactly the same information contents, but were rated as being low trust. These were the ones that people were much less likely to follow the sat-nav, even though the content was exactly the same. The paralinguistic cues had quite an impact. Here's an example of a low trust voice.
After 300 yards,
don't take it out on Yoda, but clearly the comedy voices were associated with less trust, and it affected people's behavior. Content exactly the same, as I said before. And this was our first sort of progression into thinking about voices in cars and how people anthropomorphize and start to develop the associated personality with the voice, and that affects their behavior, what they might do, and particularly things like trust. Okay, now the other thing that's sort of gone forward from that is about people's reliance on navigation systems or their engagement with the environment. And at this point back in 2005, myself and Kate Lee theorized this sort of relationship between spatial knowledge acquisition and your exposure to the environment, and distinguish between active navigation and passive navigation. Passive navigation would be like following turn-by-turn instructions, turn left, turn right, whereas active might be being more engaged with the environment, more engaged with a paper map and planning your route and these sorts of things. And you could go into these issues of the point of independence, the point at which you don't need the technology anymore, and I can navigate for myself, I can navigate for others. We started to sort of develop that, and it's only recently through the work of Vicky Antrobus's PhD that we've actually started to be able to test these sorts of things. So this was a road trial that took place in the Clifton area of Nottingham. People had to use either a sat-nav for navigating, the informed passenger, collaborative navigation, so they're using they work with a colleague, a friend, a close friend or family member, or they're using a natural language interface that we call nav. Okay. Now this is essentially moving from more passive navigation with the sat-nav all the way through to a much more active form of navigation when you have that interaction with a system and with the environment. Now, in terms of just a few results from that, people had to sketch a map afterwards. After they'd had several drives, the routes intersected, they had to sketch some maps. There were a lot more landmarks being sketched within the nav condition than there were within the passive sat-nav condition. Okay, so they're not remembering landmarks during this particular experience. Now, the particularly interesting thing is the quality of their maps. This is an example from the sat-nav condition, being asked to sketch a map. There's very little information here. They've remembered very little about this experience of this drive. They haven't realized that the routes have intersected. There's been clearly very little engagement with the environment during the drive. Compare that with a typical nav map, and they're remembering all sorts of different things. They've brought that information based on those different routes that they've experienced on subsequent drives together into a configurational whole. And they're remembering many landmarks in that as well. So you can start to see the sorts of theorized behavior actually there. Now, next one I want to talk about is predicting driver distraction. So, okay. Driver distraction is a key concern within vehicles as more visually oriented interfaces are coming in. Now, there are different issues in here. If you think about something like that interface, okay, a touchscreen interface in a vehicle, sort of a number of buttons there for you to press, and you had another one here with also touchscreen interface in the car, number of buttons to press. You said which one of these HMIs would be more distracting? Most people would say A, because it's got more buttons, maybe the buttons are a bit smaller, and that's a relatively easy thing for you to be able to say. A is worse than B. But when you get into how distracting is that, okay, that usually would require you to do a set of user trials. We get in a number of people, maybe 20, 30 people. We run a user trial. They wear eye-tracking glasses, maybe in a simulator, maybe out on the road. We get them to press these buttons. We look at how much time they spend with their eyes off the road. That's going to take you many weeks to do, okay, as a study. Now, then you get into question 3. Are any of these HMIs likely to be too distracting? Then you start to get into, well, what's too distracting? Then you start needing all the research in order to start talking in terms of the effects of your eyes off the road, time on your likelihood of a crash situation, about wavering in lane or going into the back of the car in front. And there's various sort of research that we've been involved in and others sort of looking at those sorts of things. Now, what we've got into is, okay, you can model these sorts of things. You could bring science to it and actually predict how much distraction would be involved in these situations. Okay, so this was just a couple of quick videos just to show this sort of thing happening. So this is in the driving simulator. The red thing is an eye trace. This is what they're looking at. So just one button on a touchscreen. One button on a touchscreen associated with one glance. Okay, and it'll have a certain duration. You can model that very clearly. If you then go to 36 buttons on a touchscreen that they have to scan through, now there's maybe 4 glances. And those glances are longer as well. But people are quite predictable in these sorts of situations in terms of the way that they do these sorts of tasks. And you can then put that forward into equations. And this was the sort of set of work we did with Jaguar Land Rover that was that allowed us to develop a whole series of different predictive equations that goes into here. So now we can take our 16-button interface, and we can predict the amount of time with the eyes off the road would be about 3.6 seconds. Okay. Now, if we then look at the other one, where we've got 8 buttons and they're bigger, now we're saying the predicted eyes off road time is almost half that. Okay, and that's given us some really nice data. We didn't have to run user trials. We got some really good, reliable data. We've done various Validity work with this, and it is very powerful as a method. Now, the third thing I want to talk about is about driving simulators. Driving simulators is also quite a big part of my story since about 2001 when I first started. So I got a startup funds from the School of Computer Science as a new lecturer, and I got some software for a driving simulator. And this sort of driving simulator is sort of increased in complexity over the years. It's now a full car. Audi TT, spray painted matte black, so it looks a bit like the Batmobile. Another one of my favourite films. There's a film references coming in here. And there are various advantages for driving simulators. There are various concerns about driving simulators. This makes me laugh. This is Kyle in this pretending to press buttons on the touchscreen. I'm going to pretend to press a button. Yeah, driving simulators are important research tools for what we do. We need to, but we need to understand validity. Now, by validity, I mean to what extent are people actually behaving in the simulator as if they were behaving in the real world? Okay, and there are a number of different things that you can do in order to enhance validity. Now, what we've got into more recently is about, well, how can you do driving simulator studies with cars that people don't have experience of yet? Level 3, level 4 automated vehicles, for instance. They don't exist. You can't really bring someone in and just have a one-off experience with a driving simulator, in a driving simulator. It's just not, it's too far away from what their everyday experiences are. They need to experience this technology over an extended period. So we've looked at bringing people back every day, for instance, for a week, to have something like a simulated commute. They come in every time, at the same time every day, and they experience a half-hour commute in the simulator. We can see with something like a level 3 vehicle, and we can see how their behavior changes throughout the week. So there may be sort of lack of trust in the first day. Maybe by Tuesday, Wednesday, their trust is very high. Maybe it starts getting too high. But we can see this change over time, and this is really important. So this longitudinal, naturalistic driving simulator studies has been quite important for us. Oh yeah, I had that one. So a couple of videos to show this actually happening. Then yeah, this particular participant's going to hand control over to the car. In a particular situation, and then we can start studying what sort of natural behaviours will people do in these vehicles.
Start automated driving.
So what do you think the first thing is that she's going to do? And that's what 90% of people will do at the moment, is they'll get their phone out and they'll send a message, check their social media, you know, a variety of different things. We're about to do this study in a new project funded by the RAC Foundation, where we're going to do this with a large number of people. One of the things that is really important is we can't use eye tracking because otherwise we'll see people's passcodes. So what's the next thing that people do? So I've been told you can never moisturise too much. So this particular person is going to be given a handover request. So he's not driving, and then he now needs to drive, but he's been given about sort of 45, 50 seconds or so to get himself ready to drive. And the really interesting thing here is his move from not driving to driving, okay, and what sort of things he's going through. I think there's a lot of interesting things to start with. So the system's asking him, you know, to prepare to drive. So he's got a laptop on the steering wheel, which is interesting in its own right. I wouldn't want a laptop to go off, the airbag to go off with a laptop in front of it. Off go the reading glasses. He's having to think, really, you know, put those away nice and neatly. Now look at the way his posture changes. He's really getting himself ready to drive. He's really in the mood for it. Now he's just sat there waiting for the system to give him control. He clearly wants to drive now, okay? But the system's not allowed him to drive. He's still got a few seconds. So he's just sort of sat there ready to go for quite some time, and he's just sort of staring into space. Now he's going to decide, he's going to check his mirrors, get the mirrors all ready. Here we go. And you watch the move on the steering wheel. You see this is a really common thing for people to have to start to feel the need to feel the steering again as they get back into it. Okay, so you can see the sort of natural behaviours that come through these sorts of new methodologies that we're developing. Okay, the last one that I want to talk about is natural language interfaces. Like a lot of things in science fiction, this is these things that the technology that often just gets there. It takes different amounts of time, but the technology that might be predicted by 2000 AD, Space Odyssey, is starting to happen now with Alexa and Cortana and, you know, these sorts of things, and Siri. Now, there's considerable potential for natural language interfaces. So what I mean here is like conversational agents, the chatty car, the car that you can actually talk to as if there's a passenger there in terms of the computer. There's a distraction argument. There's a comfort engagement argument, particularly potential for anthropomorphism, which I talked about for sat-nav instructions. This is on a whole new level when you start getting into these sorts of conversations. The shared situation awareness argument, like the co-pilots in aviation that you might have. But there are many human factors questions, and we've been looking at studies about level of cognitive demand. Hands-free, eyes-free does not necessarily mean mind-free. Okay, so understanding the cognitive demand is important. We've been looking at the potential for natural language interfaces to raise the arousal levels for drivers who are fatigued, who are tired. It's sort of like the equivalent of turning to the passenger to have a conversation. You may be able to do that with a speech system in the future. And we've been particularly interested working with our colleagues in the School of English here on sociolinguistic experts on the nature of the conversations, the nature of the transcripts of what sort of things people are saying to these vehicles. Okay, so here's an example of in one of the early studies that we did, and I just watch this and just pick out the different things that are going on here.
It looks like you'll be a little late for your meeting.
Oh dear.
Or no, your arrival time.
Yeah, that'd be nice.
Okay.
So there's a lot of really interesting things going on there. One is the system referring to that person by their first name, Richard, already sets up a precedent for an element of empathy in that interaction. There was a very, very efficient dialogue that went on. It was very clear when the dialogue started. It was very clear when the dialogue finished. There was clear turn-taking that was going on here. And there was also clearly anthropomorphism going on. The user praised the system. That'd be nice, thanks. It's a computer. But you see this potential, this is very, very common in what people's interactions may well be. Now, if you're sort of hearing that, seeing that interface, thinking that's really cool, I wish, you know, when's that going to be available? When can I have that in my car? This technology doesn't actually exist quite yet. And what we're doing is using this professional actor called Pablo who plays the computer. And this is really convincing. It's what they would call the Wizard of Oz technique, based off the film Wizard of Oz, where you have the wizard who's behind the curtains pulling levers, and it looks much more impressive outside. Now you can do this sort of thing with natural language interfaces and more complex adaptive interfaces, and it is very powerful. We've done this with probably 100 or so participants now. Every single participant has been convinced that they're actually interacting with a computer and not with an actor called Pablo, who's so.
Also, I looked at your to-do list and messages. It looks like you have a few things to do on your way home. You need to buy milk. Would you like me to set a reminder for you to buy milk? Okay, that is done.
So it's the clarity of the voice, it's the pauses at the particular points when data might be required. It all provides that illusion of a computer voice that is then really, really powerful in terms of the study to elicit natural behaviours. Now, the most recent stuff we've done this is taking Pablo on the road, so to speak, and do a road trial. And this is in the context of Vicky's PhD again, with a natural language interface called NAV for navigation purposes. Now watch this video and see you'll see a number of different things. You'll see the big potential for anthropomorphism. You'll see the very efficient dialogue, even when there's potential user confusion within a certain situation. You'll see the engagement with the environment, which explains a lot about the difference in the results that I talked about earlier. And you'll also see the really strong positive user experience.
Until you reach a roundabout with large tree and centre. Can you see this?
A large tree? Can you repeat?
Roundabout with large tree in centre.
Yes.
Okay. Take first left in front of her. Oh.
Got to get a landmark in there.
Would you like to hear reviews about this establishment?
Yes, I would, please.
This review. Pub and family-style restaurant. 3.8 stars out of 5 stars on Google, based on 9 reviews. Fine Gaming says 2 stars. Gary Burnett says, good.
I know him. That's Gary Spencer.
5 stars. John Wilder said, somewhere to drink. 5 stars. Paul Beckett said, would not take a dog here.
Apparently that last review didn't exist. The other ones were actually being read out by Pablo, but he just decided he was going to make another one up at the end. This is what you get with a professional actor who's very, 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 quick to do stuff. But I think this you can relate this to my overall theme. You can take the really positive perspective there, the Cartwrightian perspective of a real positive user experience. You could take the more Luddite perspective and say, oh, surely there's some cognitive distraction here. There's emotional distraction that could all affect driving, and you've got to really find that balance in the design process. Okay, so my last bit here is, so what have I learnt throughout all of this in my 25 years or so? Well, I'll say at least 5 things. If I take the first one, then impact may be realized many years after research. I'm starting to see that there's this real push in the vehicle manufacturers that I talk to on more natural forms of navigation, and landmarks will find their way. I do truly believe that they will find their way into navigation systems as a core thing as we move away from the issues associated with turn-by-turn distance-based directions. Adoption leads to new human factors challenges which are very difficult to predict. We were all about driver distraction, workload, stress, these sorts of issues. Didn't think about trust for navigation systems, behavior change or skill loss, but these became quite apparent once the technology was there. So you get new human factors challenges. So what would happen when in relation to automation is very difficult to predict. But we will, we can sort of, look at these as they arise. Don't be afraid of equations. Human factors people do tend to be quite sort of wary of these sorts of things. You don't see many equations in human factors papers, and it affects the credibility, I feel, of the discipline. We need that fundamental science, and it can really help, certainly with sort of communication with engineers. Recognize the power of the wizard. The Wizard of Oz technique, particularly for new technology in vehicles, is really, really powerful. And it's not just about natural language interfaces, but other more complex technologies is really important. And my last thing in here is seek balance in the force, or the forces. You need to provide, you've got the technology push, the technology pull. You need to sort of, human factors is very central to that, to those different understanding. You may find yourself sometimes pulling this way and sometimes pushing this way, but to be very aware of that throughout. And it feels like this was a sort of classic way to finish with the words of the Jedi Master. You see where I'm going with this. So I can get that to go. There you go. So my last thing, yeah, I had to get another Yoda one in there. Again, wasn't twice. Okay, so just to finish, this may seem like it's just about me, and mainly it is, but there are many other people who are part of this story. So this is what I will call the wall of fame or the wall of shame, depends on your perspective, but it's yeah, there are many, many people throughout my research career that have really helped me, from my PhD students to my own PhD supervisors to the researchers to industrial sponsors, my collaborators. There are many, many people. So I say thank you to all of you. Many of you are here as well for your role in this story. And of course, then there's the sort of family who are also really, really important to me. They're sort of laughing at the back. Yeah, without your support, I wouldn't have the confidence to do this. I wouldn't have the ability to be able to achieve what I have done. So thank you all very much, and thank you, just to finish, to all of you for listening. Hope you've enjoyed it, and I hope you enjoy having a glass of wine and sort of afterwards to say celebrate. Okay, thank you very much.
So thank you, Gary. That was, as predicted, a very engaging and interesting presentation that I think gave us a real insight into actually what an academic career looks like, the progression of ideas, the sort of almost the sort of peaks and troughs of how things come in fashion and fade away. And that's why it does take a long time for these ideas to come through, and it's fantastic to see them coming through, both in terms of the science, the teamwork that clearly is evident from the work that you do, as well as the partnership that you've got with industry. I'm not sure I've ever seen a lecture with so many film references in as well, so congratulations on that. So I'd like you to just join with me in thanking Gary once again, and then I believe there are refreshments outside. So thank you very much, Gary.